Welcome back. This is Mr. Hassan's Maths channel. I'm now answering questions from the October-November 2023. This is a Cambridge 9709 paper 5 variant 2. This is statistics paper S1, and this paper I'm going to go through each question individually one by one, and I'm going to record each of those questions on a separate video so that I can save my videos according to topic as well as according to paper. All right, so I'm going to start with question number 1, which is about discrete random variables. As a competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceeds 30 meters. The probability distribution table for x is shown below. So here we got the table, and we got the probability. We got the value of the discrete random variable. These are the different possible values of the discrete random variable, and these are the probabilities of each of those particular outcomes. So you have 3 attempts. All right, so let's just first talk a little bit about what is a discrete random variable. A discrete random variable is something which involves an outcome which is something that is random, meaning you don't know what the outcome will be until you've done the experiment, right? So if you say to somebody, throw this 3 times and see how many times you're going to get over 30 meters, you won't know until they've finished the trial to see, you won't know how many times they've got it over 30 meters. Okay, so a discrete random variable must be random. It can't be something that's fixed, that you know beforehand what the outcome will be. And secondly, it should be something which is like the answer to the question when you're asking about discrete random variable should always be a number which is discrete. So for example, if I said to you, if you throw a coin, what are you going to get? What could it land on? Now, the answer here will be heads or tails, which is not a number. The answer is not a number. So you can't call that a discrete random variable. Whereas with a dice, we'll say if you throw the dice, what number could it land on? Well, it could land on either 1, 2, 3, 4, 5, or 6. So the answer to that question would be a number. So it is a discrete random variable because it's a number. It's random. You don't know what it's going to land on before you throw it. And the answer is a number. You see, this is one of the things that we should understand, and this is a discrete number. So here we have an example of a discrete random variable. It's asking you to the answer to the question. If they say to you, how many times will this person throw over 30 meters in 3 throws? Well, the answer to that question could either be 0 or 1 or 2 or 3. It's possible that they don't get any throws over 30 meters. It's possible that they get 1 or 2 or even all 3 throws over 30 meters. Okay, so this is a classic example of a discrete random variable, and these are the only possible values for that particular discrete random variable, 0, 1, 2, 3. All right, now we don't have any information about the probability of each individual throw, but they've told us the probability of getting 3 misses is 0.4 and getting 3 throws less than 30 meters, 0.4, and 3 throws more than 30 meters is 0.15. Okay, and with that information, we got to find the probabilities of finding P and R, which are the probability of throwing the random variable being 1, meaning the probability that the person threw only 1 out of the 3 throws, more than 30 meters. So it could have been the first or the second or the third, and the other 2 were less than 30 meters, or the probability, we have to also find the probability of the person throwing 2 throws more than 30 meters, meaning it could have been the first or the second or the third that was less than 30 meters, and the other 2 were more than 30 meters. Okay, so now, in this question, we don't have to think too much because they've kind of given us some information that will help us, and we should understand some of the properties of a probability distribution table. So one of the things that we should know is that the sum of the probabilities will always equal 1. So I know that the probability, the sum of the probabilities, of all of those has to equal 1. So from this I can deduce that 0.4 plus P plus R plus 0.15 has to be equal to 1. And from here I can get an equation, P plus R plus, that's going to be 5 equals 1. So we can have the equation P plus R is equal to 1 minus 0.55, which is 0.45. So that's one equation that we can deduce from this information. And the other equation that we can deduce from this is from the fact they gave us that the expected value is 1.1. And the expected value is basically, like you can say, the mean. It's like the expected value is called the expectation, called the mean. And it's simply found by multiplying x by each of the random variables by its probability, and then finding the sum of all of those. Okay, so you just multiply these together, and these, and these, and these, add them together, and when you add them together, you get the expected value, which is 1.1. And that formula is actually given to you in the formula sheet, as I'll just show you. So here we have the formula sheet, which is taken straight from the formula booklet, okay, that you get in your exam. And here we're told here that for discrete random variables, the expected value is equal to the sum of xp. So it's basically the sum of these two rows, okay? The product of those numbers and then added together. So basically, we know that the expected value of x is equal to 1.1 will lead us to 0 plus 0 times 0.4 plus 1 times p plus 2 times r plus 3 times 0.15, and we know that's going to be equal to 1.1. So that's where this comes into play. Okay, so now we can just solve this and we'll get an equation with just p and r in it. So of course this becomes 0. You have p plus 2r plus 0.45 is equal to 1.1. So we have p plus 2r is equal to 1.1 minus 0.45. So we have 1.1, take away 0.45, gives you 0.65. 0.65. So now we have two equations which you can solve simultaneously. We have p plus r, 2r, let's use that one on top, it's a bit easier. That's equation 2 that we found. And we have p plus r equals 0.45. That's the first equation we found. And we can see simple elimination. If I subtract the two equations, the p will be eliminated. So 2r minus r. So I'm doing equation 2 minus equation 1. Give me r equals 0.2. And if r equals 0.2, we know that p is equal to 0.45 minus 0.2. So p is equal to 0.25. So we have our values for p and r. So we've answered the first part of the question. And that's pretty straightforward. Okay, so that formula is something that we should know. They give it to us in the formula sheet as well. So those are the formulas involving discrete random variables. Whoops. Let me use what we need to use from that. Now for part B. Okay, I might need this again, so I'll put this here. So we've worked out the value of P and R, 0.25 and 0.2. So I'll put those values in this table. And they've said for part B, find the numerical value of the variance of X. Now, they already told us the expected value of X is 1.1 from the first part of the question. And we know what the values of these two parts of the table are. They might come in handy. Now, in the formula sheet, again, they give us this formula over here about the variance of X. Okay. And, I like to remember variance of X as being the mean of the squares minus the square of the mean. So the way I like to remember the variance of X is the mean of the squares is like EX squared minus the square of the mean, which is like taking the expected value and squaring it. Okay, so this expected value is known as the mean. So this is the square of the mean. Take that away from the mean of the squares. Okay, that's what this means, the mean of the squares. Basically, what that means is you find what x squared is. So you take the x value, you square it. So that's 0, 1, 4, 9. And you do the same thing as we did earlier with EX. We just multiply x squared by the probability of that particular random variable. And the same with these, you multiply them and add them together. So that's how you find EX squared. Let's find EX squared first. So EX squared is going to be 0 times 0.4, which of course is 0, plus 1 times 0.25, plus 4 times 0.2, plus 9 times 0.15. Okay, that's going to give us the expected value of x squared, ex squared, or you can say the mean of the squares. So that's going to give you 0. So you have 0.25 plus 0.8 plus, what's that, 9 times 0.15. That gives you 12 over 5, which is 2.4. 2.4. So therefore, we can say the variance of x, which is what we're looking for, is equal to the mean of the squares, which is 2.4, minus the square of the mean, which is 1.1, all squared. Okay, so you take this answer, and from it you subtract, where's it gone? Subtract 1.1 squared. That gives you 1.19. So we know that the variance of x is equal to 1.19. So there we have the answer for part B. If the question said find the value of the standard deviation, that would be the square root of this. Okay, the variance is a square of the standard deviation. Here they say find the numerical value of variance of x, and we've done so. So there's the answer to part B, and that concludes question number 1 from this paper from October, November 2023. Okay, pretty straightforward. If you forget the formula for some of these things, some of the formulas are here for you, right? So these two relate to this typical type of discrete random variable question. Okay, so that concludes this question. Other questions from this particular paper you'll find in the playlist on the top right of the screen at the end of this video. The playlist at the bottom right will be dealing with the topic of discrete random variables from S1. And you can look at some of my questions from discrete random variables from S1 of edXL. I'll put a link here because there's a lot of questions there that might relate to this. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.